Hello, I'm James Helfrich. Today's talk will illustrate how the advent of AI has fundamentally changed the way our students will be working upon graduation, and by extension, how we need to change the way that we teach them so they can be best prepared to succeed. There's lots to this topic, so let's dive straight in. Let's begin by defining the scope of this talk. We'll begin by talking exclusively about information workers. What makes information workers distinct from other types of workers is that our output is decisions, ideas, designs, and other intellectual property. We will not be talking about nurses, construction workers, pilots, factory workers, and farmers, or others who physically alter their workplace. I'm not saying these other professions lack intellectual components, it's just that their job is not defined by it. Examples of information workers include architects who produce designs for buildings, software developers who write code which powers our computers, websites, and phones, authors who write books, news articles, and movie scripts, lawyers who create legal opinions in legal cases, business analysts who work through tons of data to help make informed business decisions, accountants who process financial data to help people use their financial resources more wisely, bankers who assess financial risk and find financial opportunities, and marketing agents who produce marketing material allowing customers to make more informed purchasing decisions. What do each of these workers have in common? They each collect and process information to create products that make our world a better place. For a moment here, let's focus on one of these information worker roles, an author. In this case, we'll refer to one who writes for a magazine. The same thing applies to many other types of authors, of course. There are three distinct roles an author can perform. Of course, there may be more or less depending on the type of author you are or the type of information worker more generally, but we'll go with three at this point. First is the typist, or a member of the word processing pool. These people translate notes and drafts into a finished product that consists of the final deliverables. The next is the contributor, those who produce the words that the customer reads. And the final group is the editors. These have the vision of what the work should look like and manage the writing process. It is important to note that all three of these people can claim to be the author of a given work. Every word was produced by the typist, the choice of words was produced by the contributor, and the entire work was managed by the editor. Of course, each plays a different role in the writing process. It is not uncommon for an information worker's career path to follow a common template. Once again, I need to emphasize that the type of information worker you are may produce significant variations in this pattern. However, for illustration purposes, we will describe a three-tier career path. We'll begin with a traditional career path, commonly used 30 or 40 years ago. In this case, we'll describe the career path of an architect. One begins as a draftsman. My mother served as a draftsman for about a dozen years when I was growing up. A new draftsman simply transcribes the ideas of the architect into blueprints, which the builder then consumes. After a few years and significant training, a draftsman can be promoted to an architect. This individual comes up with the design, which is then transcribed by the draftsman. Notice how the architect works at a higher level of abstraction than the draftsman. He might tell the draftsman to put a door in a certain location in the room, trusting the draftsman can carry out that operation. Finally is the principal architect. This is the individual who maintains the vision of the design and makes all the high-level decisions. The principal architect then relies on the architect to implement the details of the idea, and then relies on the draftsman to produce the actual deliverables. The current path for an architect has changed a couple decades ago. Much of the work done by the draftsman is replaced by software, AutoCAD in this case. Both the role of the architect and the principal architect have remained unchanged. So the question is, how does all this change with the advent of AI? The first thing to realize is that the architect will be expected to fulfill the role of the principal architect. Who will be fulfilling architect's previous role? The AI assistant will. In other words, the computers have long replaced the role of the typist, the draftsman, and number cruncher in a variety of menial information workers' tasks. However, we are now at the cusp of a new revolution where AI is now capable of assuming the role of a contributor. To see how this works, we'll divide the information worker into two distinct roles, a generator and a manager. A generator is one who produces intellectual goods. This could be the written word for the author, the legal brief for the lawyer, and the building design for architects. What does it take to become a generator? First, they need to be competent in their area of expertise. This means they need to know how to perform the job. Second, they need to be detail-oriented and produce high-quality output. No one wants to hire an author who can't write or a software developer who produces poor quality code. Third, they need to be reasonably self-directed. They must be trusted they will consistently make high-quality decisions. And finally, they need to be hardworking and finish the task in a timely manner. Note that this is how we have been training our information worker students for decades. A manager, by contrast, is not someone who primarily produces intellectual artifacts, but instead oversees their creation. Notice how the qualities of a good manager are quite different. First, they need to be capable generators. Though the numbers may vary greatly according to the discipline and the number of direct reports, most managers spend about 25% of their time in traditional generation activities, and the other 75 is spent managing the product. Second, managers need to be good at distinguishing good designs from bad ones, for steering generators in the best direction, and for communicating the direction which the product needs to go. While evaluation is certainly a part of the generator's job, it is not nearly as important as that of a manager. Third, managers own the product vision, knowing the direction in which it needs to go. In doing so, it is important that a manager let go of the unimportant details. When the manager gets bogged down in the details, the manager often loses the 50,000-foot perspective. And finally, the manager is responsible for the output of the entire team. To do this correctly, the manager needs to get the right reports at the right time and know how to interpret reports and act decisively depending on the output. Notice how the AI can fulfill the role of a generator to a reasonable degree of ability. If we train our students only to be generators, then we are setting them up for failure because they will be replaced with AI agents. In other words, the AI generators are only getting better. Now, as we discussed before, our graduates will find themselves in a management role upon graduation. They will not be managing people, of course, but rather AI agents. This means that our outcomes need to change. First and foremost, our students still need to be good at generating. Just as a manager cannot expect a human direct report to perform perfectly, our students need to be able to jump in when the AI generators get in over their head. Depending on the task and depending on the type of work, our students will still be spending a significant amount of time performing traditional new hire work. However, evaluation will be a much bigger part of what they do. They will need to request multiple options for each task and choose which approach is the best. They will also need to be able to provide direction as to how solution fragments can be improved. They need to maintain the project vision. This is a big challenge for some. They need to internalize all aspects of the project, not just the one right in front of them. At all points in time, they need to see how one small piece fits into the greater whole. Finally, they need to know how to get status reports on the progress of the project and of various tasks delegated to the AI agents. They will need to know how to process this information and how to act on the results. So how does one become an effective manager of an AI agent? It is helpful to compare and contrast the way we manage human workers and the way we need to manage AI agents. When working with people, we carefully manage the workload. We understand the human effort is precious, so tasks are carefully assigned. This is not true with AI. It takes an AI agent a few seconds or at most a minute or two to perform the task. We can ask for the same task to be done again and again and again. It doesn't mind. The constraint is no longer effort or time. When working with people, we carefully manage relationships. We use all our social skills to read body language, to watch our tone in emails, to make sure they feel valued. We all remember how we felt by an overbearing boss, and we don't want to be that guy. Similarly, we understand that highly motivated employees outperform a disgruntled one. AI agents never have hurt feelings. They are never passive aggressive and never intentionally sabotage a project. Studies have shown that current generation AI responds better if you are polite, but that is definitely not the same thing as managing a relationship. As a manager, you spend a considerable amount of time and energy developing talent. You give your workers opportunities to grow and learn new skills, knowing they will be capable of more challenging tasks and more valuable to the team in the future. The current generation of AI agents do not currently grow smarter. Their learning phase mostly occurred long before you have access to them. They do learn more about your task during a given chat, but each new chat is a new day. I strongly suspect this next generation of AI will have a more permanent context window, which will allow them to gain domain knowledge, but we are not there right now. And this is very important. With a new hire joining their team, we initially treat him or her as an unknown quantity. Initially, simple and well-defined tasks are given, results are carefully analyzed, and after a bit of time, the manager gets to feel for the capabilities of this new hire and, when this is understood, can be fully integrated in the team. This exact process is needed with AI. Every AI manager needs to make it his or her job to fully understand the capabilities of the current generation of AI tools and to explore the emerging skill set as new technologies are developed. Finally, we generally avoid bureaucracy with people. We understand that humans hate paperwork and reports. Thus, it is fundamentally difficult to get valid and timely status information. Since AI does not mind paperwork and is very efficient at generating it, the challenge becomes requesting reports which give the most insight to the process and yields the most information that can be acted upon. Simple questions such as, show me your work, and critique the quality of your solution become an integral part of how we manage AI agents. Effective management requires a deep understanding of the strengths and weaknesses of these being managed. Okay, here's the quote of the day. You can think of AI as an overly enthusiastic, hardworking, internet savvy new employee who is prone to daydreaming, but will always answer every question with absolute confidence. So, now for the big question. Do I need to totally redesign my program from scratch, taking AI into account? The answer is maybe. For an example, let's consider my discipline as software engineering. This is a traditional information worker job where the only output is the creation of code. In the distant past, we had technical leads who would oversee the code writing process, software developers who would write the code, and operators who manually loads programs into the computer and manages the physical machine, which requires a great deal of hand-holding. Once computers became powerful enough, we replaced the operators with a computer program, the operating system. Thus, the bottom tier was replaced several decades ago. Today, well, 1 year ago, I would train my students to be code generators with a future prospect of becoming a technical lead. This means I need to teach them to effectively conduct 8 individual development activities. Number 1, discovery, which means understanding what the consumer wants from their software and learns about the problem domain. 2, requirements, which is the process of systematically recording what the system needs to do to fulfill the client's needs. 3, design. Come up with a plan for fulfilling one requirement. 4, test cases, which is the process of recording how we can know if the software does what the requirement says it should do. Next, unit test, which is the process of writing code to automatically verify the software. Next, code, which is the implementation of the feature. Next, integration, which is the process of hooking up the new code to the existing code. And finally, we have release, which is to send the finished product to the customer. Now, I realize these activities are highly specific to my discipline, but I imagine your discipline has a collection of activities which your students need to master. Today, we teach our students to be developers by having a specific class or assignment focused on each activity. My hope is they'll become proficient at each by graduation. To help students be managers of technology, I need to understand AI's capabilities in each of these activities. I need to understand how the human can give the most effective instructions and how to ask for reports, allowing the human to evaluate the quality and to set the human's expectations regarding the quality of the output. For some activities, such as test case generation and requirements writing, I know AI agents are well adapted. This does not mean that I am off the hook. I still need to better understand their strengths and weaknesses, as well as teach the students to get the most out of it. Other activities, such as integration and design, I know AI is relatively weak today. So here is my challenge to you. Challenge number 1. Systematically document the different skills, activities, and tasks which generators need to do in your area. Perhaps these are well-known process steps. Perhaps you need to talk with practitioners. Perhaps you need to observe people at work and figure out what they are doing. In my discipline, this is particularly difficult. Things have changed so much in the nearly 20 years I've been here on campus, and it is a constant struggle to keep up. However, this is an essential step. It is not enough to say AI is no good at writing code. We need to break this down into the individual code writing activities. Challenge number 2. Understand the strengths and weaknesses of AI at each task individually. Experimentation may be required. I'm going to take a full sabbatical next year to do this. Note, this is not a one and done kind of thing. As AI develops and as our understanding of this tool increases, we'll need to periodically circle back and do this again. Challenge number 3. Figure out what prompts and interactions you can have with AI to get it to perform its best. Again, this needs to be revised periodically. Finally, challenge number 4. Identify reports that AI can generate so that human managers can accurately and effectively judge the AI output and give it guidance. You'd be surprised how much we can simply say, hey, think aloud, or show your work to get the data we need. I found it is helpful to train my AI what specifically to look for, and then to ask it to evaluate its own work according to my criteria. Elder Bednar gave an example such as this last month. Okay, that's it. I'm anxious now to field your questions.